It will go off in just 1 minute. Not even use it will go off. That will happen when you overcharge.
Okay, can we get started? Okay. Today we're going to be looking at motion. So today we're going to be looking at motion, very, very important. Okay, so let's look at motion, very, very important. Motion is the movement of an object from one point to another. It's very, very important concept in physics, and a lot of questions come from motion. That is what we're going to be looking at. Motion today. We'll look at motion. We'll look at calculations in motion. We'll look at the basic formulas that are used in solving motion problems. So the motion of an object can be defined as the visible movement between 2 points. And in most cases, it is caused by applied force. Now, there are many types of motion that we can have. We can have what we call the translational or displacement motion, the oscillatory or vibratory motion. We can also have what we call rotational motion, random motion, or circular motion. So I'm going to give you in a picture what these motions look like. So this is what we call vibratory motion. Similar to what you have when you plug the string of your guitar, or if you have a rope like this that is tied at both ends, if you just tap this rope here, that kind of up and down motion, we call it vibratory. Okay, we have what we call linear motion, motion from point A to point B. You can see how this man is moving, is pushing this very block from one point to the other. So motion in a straight line is called linear motion. Then we'll have what we call curvilinear motion. Motion from one point to the other, from point A to point B, but in a curved path. We have also what we call oscillatory motion. That is motion about a point, just very similar to what we have in vibratory motion. I'll call it oscillatory motion, the kind of motion that you see in simple pendulum. Then we'll have what we call circular motion. You can see this orbit, this satellite that is orbiting the Earth. You can see. So this satellite is making what we call circular motion. You can also have rotational or rotary motion. Okay, so these are the kinds of motion that we have, and by definition, translational, or you can also call it displacement motion, is the motion of a body from one point to another without rotating. Example is motion of a woman pushing a baby's pram from one point to the other in a straight line. So you can see this very pushing from one point to the other in a straight line. We call it linear or translational motion. So you can also call it linear motion. So number 2 is what we call oscillatory, which I told you is very similar to vibrational or vibratory motion, which is the motion of a body about a fixed point. So you can see this is motion of this body about this fixed point. Motion of a body about this fixed point. Oh, you can see it's moving from A to B, B to A, about this point. Okay. This motion, oscillatory or vibratory motion, it repeats itself over interval. Like once you plug this palm, it will keep vibrating or oscillating once you plug it. So that's what we call oscillatory motion. So example is the motion of a plucked violin or guitar string, or the to and fro motion of a wing of the bird or in a flight. So swinging pendulum. So those are examples of oscillatory motion. Then we have another kind of motion called a rotational motion. The rotating fan. Okay. So this is the motion of a body that moves in a cycle or ellipse and rotates about an axis. So it's rotating about an axis. Example is the rotation of fan blade about a fixed point. So rotation of this fan blade about this very center fixed point is a rotational motion. Okay, so let's look at random motion. So what is random motion? Random motion is a type of motion with no specific direction. Some people call it zigzag motion. So it's a kind of motion with no specific direction, like the particles of a gas, they just move. So example is the zigzag motion, often exhibited by gas molecules and that of pollen particles in water. So that is rotational motion. We also have cyclical motion, which is the motion of a body in a cycle at constant speed. Example is the motion of the Earth around the sun or the moon, which I've given us example. You can see moving in a cycle, the satellite moving around the Earth, or the Earth itself moving around the sun. So we'll call it cycle of motion. Okay, so these are these forms of motion in being depicted in a pictorial way so that you can have a feel of it. So this is what we call vibratory motion, like you have when you tap your guitar. This is oscillatory motion, like that of a swinging pendulum. This is a linear or what we call rectilinear or displacement motion, motion in a straight line. This is called linear motion from one point to the other to another, but in a curve. It's oscillatory motion, cyclical motion, and rotary motion. And I also mentioned the zigzag movement of gas particles as being a random motion. Okay, so let's move forward. We want to look at the equations of motion. Before before we do that, we need to understand what speed is, what average speed is, what velocity is. So speed is the rate of change of distance with time. So say a car covers a distance of d in a time interval of t, speed is going to be distance over time. That is what speed is, distance over time. So sometimes you can also say that, say that your speed is velocity. That is speed in a specific direction. So speed that has direction is velocity. So you may see speed and velocity being interchanged in some calculations. So look at average speed. When this distance covered with time over a particular journey are not steady, possibly due to traffic, then the speed can be said to be non-uniform speed. So the total distance covered over the time period can be called average speed. So once the speed is not constant, it can be talking about the average speed. So you pick the various distances, then add them up over time, taking to cover the whole of them. That is the average speed. Now, velocity is the rate of change of displacement with time. So it's similar to speed, but we are talking about movement in a direction. Okay. So those two are very important. We also need to know what uniform velocity is. A body is said to have uniform velocity if it is displaced equally in equal time. Okay, we have acceleration, which is the measure of rate at which velocity decrease can have when it is the speed is increasing. We'll talk about acceleration, but when it's going down, talk about retardation or deceleration. Okay, so acceleration is equal to the change in velocity over time. Then uniform acceleration, rate of change of velocity with time. When it's constant, then we'll talk about uniform acceleration. So we also have instantaneous acceleration, the rate of change of velocity with time at a particular instant. So that brings us to the most important thing for today, which is the equation of motion. So in your Jamb and Waec testing, you may not be needed. It's not very important that you learn how to derive this formula, but you need to know these formulas because you're going to be applying them in solving motion problems. Okay, let's look at the first one. V is equal to U plus AT. That is final velocity is equal to initial velocity plus acceleration times time. That is the first equation. Then this other equation, distance U is equal to UT plus half AT squared. So S here simply means distance. It's equal to initial velocity times time plus half of acceleration times time squared. Then you also have this very important equation, V squared equal to U squared plus 2AS. Where V is final velocity U, initial velocity, then A is acceleration, and S is distance. Okay, so these three equations, they are basic, very important. So we're going to be looking at past questions where we use these equations to solve problems. So after the break, we'll also look at other forms of this motion equation when you're considering a motion under gravity. So what you basically do is that everywhere you have acceleration A, you change them to G, which represents acceleration due to gravity. Okay. So I'm going to quickly look at some past questions relating to this so that when we get back at other times, we can look at vertical projection, projectiles, and various equations that can help us solve this. Okay. So let's look at these. Let's look at these past question problems that relates to what we have. Okay. So let's look at this first problem so that we see how we'll use those equations that we talked about to solve. So this is Jamb 2019 physics. A body of mass 5 kg starts from rest. So whenever you hear the word starts from rest, it simply means that the initial velocity is 0. That's the meaning of that word, starts from rest. So a body of mass 5 kg starts from rest and is acted upon by a force of 100 newtons. The acceleration in meter per second and final velocity after 10 seconds will be what? So you're required to find the acceleration and the final velocity. So the options that you have there are 20 meter per second and 20 meter per second. 20 meter per second squared and 20 meter per second. The option B, 25 meter per second squared and 250 meter per second. Option C, 20 meter per second squared and 200 meter per second. And option D, 100 meter per second squared and 300 meter per second. So how do you go about solving this? The best approach to use when you're solving calculation is to quickly list out the parameters that are given. You can see you have here 5 kg. So what is this 5 kg? Is the mass. So we say mass is equal to 5 kg. Then the next parameter that we are given is force, which is 100 newtons. So force is equal to 100 newtons. And the next parameter that you're given here is 10 seconds, which is time. So time t is equal to 10 seconds. Okay, so these are the known parameters. So what are the parameters that are not known or that are implied or the ones we want to calculate? So you can see that it says that the body starts from rest. So that simply means that initial velocity u is equal to 0. Okay. So final velocity is what you are required to find. You can see it here, and also acceleration is what you're required to find. So we have a simple equation that we gave. So if we look at those three equations, v equal to u plus 80, s equal to ut plus half at squared, and v squared equal to u squared plus 2as. So we're definitely going to use one of these equations to solve this problem. But before then, we need to find out the parts that are missing in that very equation. So we know that force is equal to mass times acceleration. So if we want to get the acceleration, which is one of the things we are asked to get, we are asked to get the acceleration and the final velocity. So how do we get the acceleration? With the parameters given. So we are given force. You can see force is 100 newtons, and we're also given mass, which is 5 kilograms. So with this relation, we can simply find our acceleration. So F is equal to ma. So make A the subject of the formula. A becomes equal to F over m. And that is 100 all over 50, making the acceleration 20 meters per second squared. Okay, so having found the acceleration, the next thing that we're going to be looking for is the velocity. So how do we go about finding the velocity? So from this formula, v equal to u plus at, I gave us this formula. V equal to u plus at, that is the formula that we are using. So with this formula, you can easily get our velocity by simply saying v is equal to u plus at. What is the value of u? Initial velocity is 0. So say 0 plus, what is the value of a? We've gotten a here to be 20 times what's the value of t time, which is what, 10 seconds. So you have 0 plus 20 times 10, which is 200. So making v equal to 200. So the right answer is acceleration 20 meters per second squared, whereas velocity is 200 meters per second. So you can see that we are able to utilize that equation of motion v equal to u plus 80 to solve this, but we're able to do this after getting the value of acceleration because we know the force that is producing the motion. We know the force and the mass, so we can easily get the acceleration from there. Okay, so let's move forward. So we have this other one. A car accelerates from 3 meters per second to 100 meters per second. So you can see the movement in the acceleration. Accelerating from this to this. It's actually accelerating. It's not decelerating. It's not going down. And this acceleration was done in 35 seconds. So calculate the acceleration of the car. So a car accelerates from this to this. So this is the velocity is moving from this to this. So when you have this change in velocity from this to this, so it means that it's actually accelerating when the velocity, the quantity is increasing from 3 to 1000. Okay. So having this velocity change over this time, what's going to be the acceleration? So it's very simple. So we still use the same equation like we used before, which is V equal to U plus AT for making A the subject. So if you make A the subject, we're going to take you over to this side. So you have V minus U. So if you want to leave A alone, then that will be over T. So that's how we came about this V minus U all over T. So we're using the same formula, the first formula. So having this formula, you can simply, you know what A is what you're looking for. V is the final velocity, which is 100 meters per second, whereas U is the initial velocity, which is 3 meters. So if you simply do 100 minus 3 all over the time, which is 35 seconds, you get the answer. So I don't know, is anybody following that can be able to solve all this and tell me the answer? Is there anybody that can do that? Can anybody do that for us? Okay. Okay. So if you're able to solve this, A is equal to 100 minus 3 all over 35, which is 97 over 35, which will give us 2.77 meters per second square, which can approximate to 3 meter, 3 per meter square. Okay. So that is the acceleration. Okay. So let's also look at these. A train with an initial velocity of 20 meters per second. So the initial velocity is 20 meters per second. That is the U. Is subjected to uniform deceleration of 2 meters per second square. So this velocity is actually going down. So the uniform deceleration is at 2 meters per second square. So we have our A, but this time around is going down. That deceleration minus A. Now the time required to bring the train to a complete halt, that means the final velocity is going to be 0 because it's stopping. So what is this time? Is it 40 seconds? Is it 10 seconds? Is it 20 seconds? Is it 5 seconds? Okay. So the same formula like we used before. A is equal to V minus U over T, which we got from V equal to U plus AT. Okay, remember, deceleration means decreasing acceleration or retardation. So in this case, we are going to use our acceleration to be minus A. So here we have minus a equal to v minus u over t. So this negative sign is actually from the fact that it is decelerating. Okay, so we know that because they say that the body came to halt, so final velocity is 0. Initial velocity, as is mentioned, there is 20 meters per second. So time is what we are looking for. So we're going to make t the subject. So if you substitute everything, deceleration is minus 2. You can say it here. Final velocity v is 0. Initial velocity u is 20 meters per second. Then all over t. So make t the subject. That's what we're going to do. So cross multiply. So you take this t here. So you have minus 2t equal to minus 20. So cancel out the minus. So we now have t equal to 20 over 2. So we give 10. So 10 seconds is the right answer. Okay. So we're going to continue solving more problems in motion. But I want to make sure that we're following through. Okay. So let's look at more problems under motion. Okay, which of the motion do the wheels of a moving car? Which type of motion do the wheels of a moving car undergo? So a car that is a car that the wheels. So when you're looking at the wheels of a moving car, what kind of motion do you observe there? Okay, is it random and translational? Random, that's motion of a gas, no? Is it rotational and oscillatory? That's the motion in a blocked string or a swinging pendulum. Is it translational and rotational? Okay, translational, that is linear because the wheel is moving from point A to point B. So there's definitely translational. The rotational, yeah, because the hands of the wheel, you can see that the hand is moving around the axis. That's rotational. So is it vibratory or translational? Vibrating? Is there anything moving about a point? No, nothing like that. Okay. So to get the grasp of these, we'll know that let's try to take out the options that cannot be the answer, like random. What is random motion? Random motion refers to irregular or haphazard or disorderly motion with no preferred direction or orientation. Example is the primary motion, motion of very small particles, the motion of gas molecules. So that is random motion. Now, translational motion refers to motion from one point in space to another without rotating. So a car, that's the kind of motion that you have a car move from one point to the other. The whole car, okay? Now, oscillatory or vibratory motion refers to and fro motion of a body about a fixed point, like a rocking car. Okay, rotational motion refers to motion of a body in a concentric circle, like the earth rotating the wheels of a moving car. Okay, so the wheel of the moving car undergo both rotational and translational because the wheel moves the car actually from one point to the other. while making a rotational motion, and that makes option C the right answer. Okay, and let's look at this Jamb 2014 question. From the diagram above, the region of zero acceleration. How do you know zero acceleration in a velocity time graph? So under motion, this is very, very important. The velocity time graph shows you how you can dictate acceleration. You say that acceleration is the rate of change of velocity over time. So you can see that the velocity is changing over this time. The velocity is increasing from what it was here to this point to this point. But at this point, it's no longer increasing. So if the velocity is not changing over time, then you can say that it's not accelerating. So velocity change over time is acceleration. But you can see here from n to s, there was no change in velocity. So the change is zero because it has remained constant at this point. So at this very point, the velocity did not change. And when the velocity did not change, we talk about zero acceleration. Okay, so here again, you can see the velocity is changing over this time. We have movement from S to P, there is still change. And at point P to Q, talk about deceleration because velocity is changing. But this time around, instead of increasing, it is decreasing. So we'll talk about deceleration. So the point of zero acceleration is actually at the point between N and S. And that makes option B the right answer. Okay. Okay, so let's keep looking at problems. Let's keep looking at problems so that we can understand these perfectly well. Okay, so this is the solution to what we just did. Region MN and SP represent uniform acceleration, that is the velocity of the body increased by equal amounts in equal time, therefore acceleration is increasing. But this region of N and S is the region of constant velocity. Velocity was not changing, so acceleration is actually zero. So region P to Q represents deceleration, that's velocity decrease with time. So here you have negative acceleration, which we call deceleration or retardation. Okay, so that makes NS the answer. Okay, so let's quickly look at this other question, Jamb 2014 physics. A car accelerates uniformly from rest at 3 meters per second square. Acceleration. Its velocity after traveling a distance of 24 meters is. So it's accelerating from rest. That means initial velocity is zero. Okay, so we see the second equation that we are told of, v squared equal to u squared plus as. That is the equation we're using for this very problem. So v is the final velocity. That is what we are expected to calculate. Because here we asked, what is this velocity after traveling a distance of 24 meters? So initial velocity u is equal to zero because this body is starting from rest, it's accelerating from rest. Initial velocity was zero. And they told us that the acceleration is 3 meters per second squared. So distance is what we are looking for. So we're going to make s the subject of the formula in order to get this. So if we insert what we have here into this equation, v squared is what we are looking for, equal to or zero, which is the initial velocity. Zero squared is zero. Okay, yeah, we are looking for the final velocity. So we have we are not actually making S the subject. V should be the subject. So plus 2as 2, we have it here. A is acceleration, which is 3. S is 24, which is distance. So if we multiply this out, we're going to get 144. So to get D, we're going to have square root of both sides. So we have root of 144, which is 12 meters per second. So that is the final velocity. Okay. Okay. So we're going to look at one more problem before we close. Let's look at one more problem. So I'm going to send these solved problems to the WhatsApp group chat so that you can see them and be able to look at them once again. Okay, so let's look at this final problem. Let's look at this final problem. Jamb 2012 physics. A car starts from rest. You can see whenever you hear starting from rest, that means the initial velocity is 0 and moves with a uniform acceleration of 30 meters per second square for 20 seconds. So this is the acceleration and this is the time. Calculate the distance covered at the end of the motion. Is it option A, 6 kilometers? Is it option B, 12 kilometers? Is it option C, 18 kilometers? Or is it D, 24 kilometers? Okay. So using this very formula, S equal to UT plus half AT squared, which is one of the 3 formulas that I gave us. See, we've been able to use all the formulas. So depending on what the parameters that are given, that determines the formula that you use so that you find the unknown. Okay, S is distance, U, which is initial velocity, 0 meters per second, because the object of the car is starting from rest. T, time is 20 seconds, A, acceleration is 30 meters per second squared. So put all these into these, you're going to find your S. So S is already the subject of the formula. U is 0 times T is 20 plus half A is what? 30 times T squared, which is 20 squared. Okay. So you put this together, you are going to have 0 times 20, making this 0. So you simply have half 30 times 20 squared. 20 squared is 400. So half 30 and 20 squared, that's what you're going to have. So 30 times 400 is 1,200. I mean 12,000. 12,000. 30 times 400. Okay. So half of it is that's 12,000 over 2 is 6,000. So this is a meter. So if you're going to convert it to kilometers, it's going to be 6 kilometers. So that makes option A the right answer. So you can see that in these problems, we've been able to use the 3 equations. B equal to U plus AT. Use the V square equal to U squared minus 2AS, and use X equal to U plus half AT squared. So those 3 basic equations of motion, use them, solve the problem, and answer the theoretical question. So I'm gonna sign out and log back in. So I will look at some base number calculation in mathematics. Okay. I hope you enjoy the class. Very importantly, you know that we have our flash. The flash drive contains our lectures and in such a way that you can use them on your phone. So this is the flash drive. Once you chat me up on WhatsApp, my phone number is 070-671-62698. If you're not in Nigeria, my phone number is +234-70-671-62698. So it's flash drive. It has one port here is for phone and the other is for flash. It's for laptop, so you can use it on either your phone or your laptop. It's very, very good. So it has our lectures according to curriculum and some past questions and answers in video format. Understand? If you're in sciences, we have for sciences and we have for arts. So it's very good for you to practice along. So even as we come online, Facebook Live, YouTube Live to teach, it's also good you have these so that your child can use them on their phone and be updating, getting prepared. The kind of classes we are having is the past question based. Immediately we finish the classes, we'll go to look at problems that are related to that in the past question. By so doing, it exposes the child to what he or she needs to prepare on in order to write the Jamb and score very good. Okay. So chat me up for the flash. You need them. I'm gonna be signing out and joining up later. Thank you. God bless you. I'll see you when I see you.